Hello, hello, and hello to the amazing, wonderful class of physical science. A couple things. This is your teacher, Braxton, speaking. This is going to be awkward, and that's fine, but I think it'll be funny. And more importantly, I think it'll be educational. So, couple things. I know we've been snowed in. I know that we haven't had the best run of class time, but that is okay. Okay, I will not let this weather cheat you out of your scientific education, especially for you young chemists and young physicists out there. So we had just finished a chapter exam. I still have a couple people to take it, but that's fine. Moving forward, these next couple lectures for Wednesday and Thursday's lectures, since we're out of school, I'm going to try and record them and post them as I'm doing now. I won't have as many distractions in class, which is both saddening and uplifting in some senses. So these lectures shouldn't be terribly long, probably between the 10 and 15 minute range. This one will probably go longer because it's my first one, and I'm giving you a lot of background information. But nevertheless, couple housekeeping things, okay? I do not know when I will see you again in class, okay? I pray that it is at the right time, but a couple things have come up, which is a blessing. Been truly blessed by the good Lord himself. And so I probably will more than likely not be in class Monday and Tuesday, okay? I probably will not be there Monday and Tuesday, and the rest is up for debate. But never fear, for the internet and technology are here, and the good Lord is on our side, and I pray that he lets these videos upload in a timely manner for you to watch them. But basically, long story short, is I'm going to record at least 1 or 2 lectures and post them. I will post my notes. You have my email. You could email me if you have any questions. I'm open to questions. I'm open to answering them. I'll answer them as fast as I can, and hopefully I will figure something out regarding next week. But I will let you know in time. So basically, make sure you're updated. Make sure you stay up to date with Google Classroom, and yeah, we shouldn't have too much go by. But with that being said, let's go ahead and get started. We're going to be talking about kinematics, okay? Well, before even then, let me back up a little bit. Pretty much the rest of the semester will be about physics, okay? God bless your soul, okay? I pray that he blesses mine too. Physics, I'm not going to lie, it's fairly tough, okay? It's it can be hard to imagine. It can be hard to put things in a practical sense, and that's fine. Bear with me. I will help you. I will be with you every step of the way. Keep in mind a couple things while I'm thinking about it, praying about it here, what to say, is I think it would be very, very beneficial for you to try and do as many practice problems as you can, okay? One big thing I always say, at least in my biology class, I need to start saying it more in the physical science class, is you have to know the definitions, okay? You need to know the definitions of words, especially the bold and most of the italicized ones in the chapter, as they they will help you out a lot, okay? Know the definitions, not only just knowing them, but how to use them and how to interpret them and how to play with them in an example, okay? You should be able to make up your own example using the definitions, okay? I will try to do one of those for you today. I'll try my best. One of the examples given in the book, I'll try to explain it. But know those examples, okay? Know the words and how to use them, okay? That's going to be huge in your study for kinematics, as in physics in general, okay? Without further ado, kinematics. Kinematics is simply the study of motion, not the study of motion, but how things move. Kinematics is the study of how things move. And so we're going to talk about that today. Okay. First things first is, let's talk about Jesus, all right, the literal visible image of the invisible God. Motion is very important. People have been studying motion for a long time. They have been wondering about how did these things move? How did this get here? How did that get here? All the way back to the beginning of Earth, depending on who or what says who or what about when it started and how it moves. But there's no debate that it was divinely put together. Well, anyway, there's no debate that the world is perfectly put together. The universe is perfectly put together. The orbit, the electromagnetic field, the push and pull of the cosmological constant, all these smart people things that I'm not too entirely concerned that you know, and quite frankly, I'm not too concerned that I know them either. But the point is that God made the world exactly how He wanted to, and it is good. Okay, we see here early in the book it gives a reference to Genesis 1:14. Hint, hint. All right. On the fourth day, God purposely created the sun, the moon, the stars, so that motion would mark out the days, the seasons, and the years. Okay? So from the very beginning, we see a very, very, very divine creation of motion and how things move. Okay? Let's keep going. Kind of diving into the chapter. We're going to talk about 3 early definitions. They're at the bottom of this first paragraph in your chapter, in your book. Okay, the study of motion. The study of motion, that is called mechanics. Okay, the study of motion is called mechanics. Think about when you go to the mechanic, take your car to the mechanic, he fixes it up or she fixes it up. You want to get your car moving again. Okay, you want it moving well. That's mechanics, the study of motion. Very important that you know the study of motion is mechanics, and that what we're going to talk about in this chapter is called kinematics. Okay? Kinematics is how things move. This is the study of how things move. Okay? You think of the mechanics as the what and the kinematics as the why. Why do things move? How do they move? Okay? And then part of that why in kinematics is the study of motion and why things move, called dynamics. Okay, to be dynamic is to change. We will talk about dynamics later on in the semester, but kinematics is the study of how things move. Dynamics is why things move, and mechanics is the study of motion. Okay, so one more time: mechanics is the study of motion, kinematics is the study of how things move, dynamics is the study of why things move. I think I said why for kinematics, but the why is dynamics. The how is kinematics. The how is kinematics, okay? So, truth be told, I am not entirely concerned too much if you know these bigger paragraphs with some of these older scientists. Galileo, you probably heard of him. Sir Isaac Newton is one that studies motion. You might have heard of Albert Einstein before. Okay, a lot of these guys are credited with studying a lot of motion and physics. These are big time physicists. Galileo, I think, is the one with the best known for study on like the stars and astronomy. Isaac Newton is arguably one of the people that found it. He's discovered the 3 laws of motion. Isaac's 3 laws of motion. Credited with discovering gravity and part of calculus. Not that you care about that probably, and then Albert Einstein, the speed of light with E equals mc squared. Okay, not entirely concerned that you know those names and what they did, but that's just a little background on the study of mechanics, kinematics, and dynamics. Those men are attributed a lot of this study. Okay, but let's get into the meat and the potatoes of this video. The first thing we're going to talk about, okay? So, when we talk about physics, it is a very general term, okay? We're going to talk about some things, and I'm going to say some things this semester that you're going to be like, what? That's crazy. That doesn't even make sense. And truth be told, you're probably right in some sense, okay? But It's very important that you lock in and understand the definitions and how to use them the right way, okay? Because if you use them the wrong way, it's going to be counted off. You're going to miss it, okay? You're going to be upset, whatever. So the first thing we need to talk about is frames of reference, okay? And this probably sounds somewhat familiar to you, and you're probably right, okay? A frame of reference is just how we see things, okay? What are we using to describe the motion of the object, okay? Kind of like the term perspective. The frame of reference is kind of like the perspective. So let's talk about motion. Let's talk about how things move. Kinematics, how things move, kinematics. Let's say you're sitting at your desk at home or on your bed or wherever in the living room, and you're watching this video. You're sitting in the chair, right? Are you moving? I'll give you an awkward few seconds to sit there and think about that. Are you moving if you're sitting in the chair? This is really weird because there's no one like raising their hand or anything. And the answer is yes, okay? You technically are moving. Technically everything is moving at all times. And that has to do with the particles of matter you've learned about probably in earlier chapters and earlier in your education. Long story short is that pretty much everything is moving all the time. And it's either vibrating or slipping past each other or moving frantically by each other, depending on the state of matter. But when we talk about motion, we talk about the frame of reference. We need to talk about what it's moving in relation to. So let's say you're at your house and you're at the kitchen table, you're watching this video, and your parents are cooking you something to eat, right? And you say they're moving around the kitchen, but you're not moving at the chair, at the counter, at the table, whatever. That's because the frame of reference is the room or rooms that you were in, right? So the frame of reference, by definition, is a coordinate system that we can use to describe the motion of an object, okay? For example, the example I've been using, if you're in the room and your parents are in the room and they're cooking while you are sitting watching this video, you are not moving, but your parents are moving. That is because the frame of reference is the room, okay? You're looking at it from the perspective of to the room. Okay, let's try another example. Let's say you're on a train. Okay, this is one of the examples in the book. You're on the train with you, and let's say your sibling is sitting with you. Well, let's say, I'm going to change it up a little bit from the book. You and your sibling are sitting on this train that's traveling due west. You're going out to see the Grand Canyon. You're sitting on this train. Are you moving? Yes, no, depending on your definition, your frame of reference. But let's say your mom is up in the train car and she's walking up and down the train car going somewhere. Well, if you're sitting there, you and your sibling are looking at your mom like she's moving because that's your frame of reference. But to your mom, who's in the train car as well, you are not moving, you and your sibling. So the frame of reference is that your mom is moving, you and your sibling are not moving because you're in the train car. But let's say that I'm standing outside the train car, like on, let's say I'm sitting, let's say I'm in a diner that you're passing by and I see the train go by me. What am I going to say about all three of you? Am I going to say that you and your sibling are sitting still and that your mom is moving? Probably not. My answer is probably going to be that all three of you are moving because you're all in the train and I see the train going by me. Okay? That is frame of reference. Okay? It's pretty much a fancy depiction of perspective. Depending on your frame of reference, depending on what you're comparing it to, depends on whether an object is moving or not. Okay, or how fast it's moving or whatever. For example, your mom walking up and down the train car, she might be moving pretty fast in terms of the train car. But in terms of the world spinning, she's probably not moving very fast in comparison to how fast the Earth spins on its axis. Okay? Again, I know these are extreme examples. I know this is kind of a tougher concept. Watch it a couple times. Listen to it a couple times. Email me. We'll talk about it. Okay? I will do my absolute best to be back in the classroom to show you this stuff, to explain this stuff in better detail. But hopefully you're trekking along. Okay? So that's frame of reference. That's